Hey guys, today's episode is sponsored by Westermeyer Industries Serviceable Oil Floats. Many oil separators contain an oil float to effectively meter separated oil back to the compressors. Westermeyer Industries has taken this concept and perfected it with their new line of serviceable oil floats. These floats feature an improved design with fewer components, allowing for greater manufacturer consistency and up to 20% increased oil flow versus their legacy models. These floats also feature an integrated magnet to shield the oil path from debris and have been field proven in supermarket applications. Westmeyer Industries offer replacement oil floats not only for their own separators, but also cross-compatible models for our competitor oil separators as well. You can find out more about the Westermeyer Industries serviceable oil floats by visiting westermeyerind.com/floats. Once again, that's westermeyerind.com/float. Let's get on with the episode.
Hi, guys. Welcome to the Advanced Refrigeration Podcast. I'm your host, Kevin Compass. I'd like to take a minute to talk about one of our sponsors, Parker Sporlan, and thermostatic expansion valves. How can you guys always have the right thermostatic expansion valve for the right application without having to carry hundreds of valves in your truck? Well, that's simple. Using Sporlan's interchangeable cartridge-style valves. The Q valve for conventional and the BQ valve for balance port. It's as easy as 1, 2, 3. It serves thousands of unique applications. So 1, you just select the thermostatic element for your application. 2, you select the body style you need. 3, you select the right size cartridge for the application. These easy to select and assemble valves mean you always have the right valve for the job on your truck. For more information on the Q and BQ valves, visit sporlan.com. Thanks, guys. Enjoy the episode.
Good evening, everybody. Welcome to Advanced Refrigeration Podcast. You're here with your hosts, Brett Wetzel and Kevin Compass. What's going on this week, man? Are you out of town?
No, I'm in town. Just doing some more prep work on my my rack changeover and starting to kind of piece everything together and line up all the stuff for us to start cutting everything over next week. And then other than that, just running some service calls in between to kind of fill in the time. What about you?
Working on stuff at home. Trying to get some videos out, working on some other projects. Just always staying busy.
Oh,
So,
yeah. I've recorded like a ton of E2 training videos.
Yeah, I'm gonna start editing those this weekend.
That hopefully will be out soon for you guys.
Sounds like a plan. So tonight we're going to be talking about split valves and split condenser. Kev, you want to start off?
Yeah, that's fine. I'll start off. All right, guys. So it's cold out. It's hitting. It probably got to like 40 degrees in Texas, and hit for all those guys out there. And that's cold to you people. What was it last week? Did it get colder than 40?
It was actually about 18 last week, to be honest with you.
Surprised the whole state didn't shut down again.
Well, there was no precipitation, so we're good there. As long as it doesn't snow, everyone's fine as far as driving, but they can deal with the weather. Actually, it's funny that you mentioned that we're talking about this now. A guy was at a store, and the receiver levels, he sent me a picture of them, and both of them were at 50% at one point, and then it just dropped off to nothing. And I didn't the last thing I told him to check, because he was intermittently calling me back every time he'd find something new, and I said, you were at 50%. There's no way that just disappeared unless both racks got hit by a forklift exactly the same time. You'd have to check out the the split side of the condenser, and lo and behold, I didn't get a phone call back after that. So I think he found what was the problem.
Yeah. So we'll go over this since everybody's like experiencing this cold snap and just go over it. So why do we split the condenser? Okay. We split the condenser because we need to reduce capacity in the condenser. Because if we're running full condenser and it's 18 degrees outside, we now have a condenser that's way oversized. So we're not going to be able to maintain that head pressure. And we're going to have to do it with flooding valves and fan cycling. So the reason we split the condenser is we cut that condenser in half. So now we decrease the size of that condenser, and we decrease the refrigerant charge needed to maintain that condenser running in the wintertime. Now, we do this a couple ways. You could do it with a three-way valve, splitting it. You could do it with actuated ball valves. You could do it with a CDS valve. You could do it with solenoids. There's all kinds of types of ways to do this. There is 50% split. There is 100, 75, 25, 50% or 25%. I've seen it split 4 ways. I've seen them split 5 ways. It all depends on how you load up a rack and how it's designed. But that split is there to reduce the actual size of the condenser. So that way we use less gas and we have to flood the condenser with less refrigerant. That is its main purpose. Because if we had to take a 12-fan condenser, let's say, and flood it, you're talking hundreds of pounds of refrigerant. Okay, if you take that same 12-fan condenser and you cut it in half now, you're talking half the amount of refrigerant to flood it. So that's why we're doing this. And in certain climates, like say Florida, for example, it's not getting to 18 degrees really in Florida ever. So say Florida gets to 50. Okay, they could split the condenser and use fan cycling and be fine and maintain a good quality head control, pressure. But up here in Chicago, there are times when last year when it was like minus 10, minus 15 for like 3 days, I had a couple racks where the fans hadn't come on in days. We were just running on holdback valves with split condensers. And if we wouldn't have had that, we would have never been able to maintain our saturated condensing pressures.
You guys got to remember whenever you go down in temperature, like if it's sized for 120 degree ambient, basically if the ambient temperature gets down to 60 degrees, basically half of what it was originally designed for, that condenser is now double the size. And that's why we're able to actually split the condenser. Same thing, same principle with single condensing units. A lot of times Bone will put a thermostat in there that splits at 60 degrees, or a thermostat that shuts off at 60 degrees. So basically you can shut off one half of your condenser and still have the full capacity because of the ambient temperature.
Correct. And obviously there's a couple, caveats to this. We got to make sure we do. We obviously got to make sure we get the refrigerant out of it, because you don't want to have all the refrigerant sitting in the condenser all the time. So you need to have a pump out line. You need to pump the refrigerant out. So this is something I see guys miss a lot, especially in areas where they don't have a lot of colder ambience. So you'll actually log gas inside the split side of the condenser. So there is a pump out line that's pumping out the refrigerant. So you either have a separate pump out line, or if you have a three-way valve, Sporlan makes a B-type three-way valve. The B is a pump out style. So anytime you see a B-type three-way valve, meaning it has a built-in pump out, not the fastest. So a lot of people will put a pump out solenoid in. Sporlan makes a great pump out solenoid, and it's an orifice solenoid. Works great. Or some manufacturers like Hussmann, they'll put a orifice, like a fixed orifice on, and use a solenoid on that to pump it out. Or Hill Phoenix will use a cap tube. Not a big fan of cap tube. There's a big leak potential there, but they all work. You just need to get the refrigerant out of there. because if you leave the split side full of gas, it'll log and it'll sit up on the roof because the refrigerant always wants to go to the coldest spot. So like first things first, when I'm troubleshooting racks, or like I have receiver level calls in the wintertime and I'm in split, the first thing I do before I do anything else, I'll look at the receiver, but first thing I'm going to do, as long as there's no gas spraying out of the room or oil everywhere, I'm going to walk right over to the split side, throw a gauge on it, and see what the pressure is. If it's not a suction pressure, I'm going to, break out the recovery machine or do whatever I got to do and start pumping out the split side and figure out what's going on. Because either you have a check valve bleeding through, you have a solenoid, or the whatever split device is not working, or your pump out's not working because all your refrigerants, logging in that side of the condenser. So that's one thing to, keep in mind, especially when you're troubleshooting this stuff, is, make sure that split side is completely empty of refrigerant, pumped out down to suction pressure. And some things can be deceiving. Like we've had this before, when guys will go check that. Okay, but if it's on like a plus 18 rack and you don't have a check valve on the pump out line, it could actually go backwards into the condenser. So if it's colder than plus 18 outside, it'll actually condense gas in the condenser from the suction.
Yeah, usually that pump out line, depending on the pressure of the rack. So low temp racks will typically pump out a little bit faster than medium temp because of how low the suction pressure is. But typically it takes anywhere from 3.5 hours, as long as you're not splitting right when it's 0 degrees outside. Typically whenever it's called upon initially at the 55, 60, 50 degree range, it should pump out with, typically within 3 to 3.5 hours. Sometimes there is screens in front of these solenoids that can be blocked, potentially taking a lot longer. Kevin was referring to the check valves on the liquid drop leg side. Typically the way that things are piped in, you have your two lines coming from your discharge, split either with, like you said before, the three-way valve, normally open solenoids, CDS valve, whatever have you. And, basically you have two drop leg check valves on the drain leg. And the reason why you have that is really for pressure drop. Typically, you're not splitting the other side of the condenser. So technically, if you really think about it, you wouldn't need it, but we need it so we have even flow across that condenser. Same reason why we have two normally open solenoid valves on the discharge line a lot of times, and we're never ever going to shut that other one. Reason why is pressure drop, so we don't have more refrigerant going through the one side than the other. Basically you have three things going on at one point during the split. You have the discharge line shutting off, you have the fans shutting off for that side of the condenser, and then you have the pump out line activating to get that refrigerant out of that side of the condenser.
Yeah, I mean, so I want to go over one thing because I see this a lot in stores we have. We have certain stores that have their split. They'll have solenoids, okay? Well, it won't be just one solenoid. It'll be like 4 solenoids. So you'll have 2 in a row or 2 in parallel for the split side, 2 in parallel for the non-split side. So I see this all the time. You'll see you'll be getting pressure back through. So the way I troubleshoot this, if I have like a slight bleed through. So generally, most manufacturers will put check valve. It'll have your drop leg piping be coming down. It'll be check valve or pump out line. I'm sorry, no, it'll be ball. It'll be coming out from the condenser. It'll be ball valve. Then it should be pump out line, a tap, and then a check valve. So your drop leg check valve should be after the ball valve. So what I generally do to see if it is bleeding, if the check valve is bleeding through, I will take and I will shut the drop leg ball valve off. I will pump the line out to like 5 to 10 pounds, and I will watch it. And if it does not drop to that 5 or 10 pounds, or if I can't get that little section of line to pump out, I know that check valve is bleeding through, and that's my problem. Now, if it doesn't bleed through, and it's holding pressure. If I get it down to like 10 pounds of pressure or down past suction, and I know that section of pipe, because you're talking 2 feet of pipe between the ball valve and the check valve and the pump out line, I know my problem is now at whatever splitting the condenser, whether it's the solenoid, CDS valve, the 3-way valve, then I move on to that. Now, if I have a setup with multiple solenoids, generally what I can do, see, I have a thermal imager, so I'll use that. That's my cheating trick. I can use a thermal imager and see which solenoid is bleeding through. If you get lucky, you could see it with a temp clamp. Usually, the one will be slightly warmer because that discharge gas is sneaking through there. But a lot of times, you may have to end up rebuilding both those valves, whether they're E42s or OE35s. And those valves should be normally open. So you don't want to see an ME valve there. You want to see an OE valve or a normally open valve. You don't ever want to see a normally closed valve on the split valve. The reason being is you're never going to, if you go into fail safe and something happens to refrigeration, you're going to shut the condenser off in high head.
And remember the difference between a normally open and normally closed solenoid. Obviously, one's normally open, one's normally closed, but physically, the normally closed will just have a regular 5/16 screw holding the solenoid coil to the actual stem. When you have a normally open solenoid, typically there'll be a spacer on the top of the solenoid. Also, you can tell the solenoid coil itself. We're typically used to MKC1, MKC2. A lot of times you'll see OMKC2, and that's a normally open solenoid. The big difference, the coil basically has a hole in the bottom as well in the top, so it can set on that stem at a certain height. There's typically a spacer on the end of the stem, as well as a 7/16 nut on the top, and that physically you can see which valve is which just by looking at that. Because I've seen during a remodel, retrofit, they ended up putting in a normally closed solenoid on one of them, and I had crappy flow. It just wouldn't, my head pressure was exuberantly high during this retrofit, and basically it was because the contractor had installed normally closed solenoids on not all of the solenoids. Otherwise, it would have went off on high head. So just be mindful of that.
Yeah, I mean, the other thing I've seen CDS valves used, and I mean, they work pretty good. So, I mean, they could step it down. The benefit to using a CDS valve is you could slowly open the other side of the condenser, so you aren't slamming it with hot gas. So you could open it slowly. I've also seen Sporlan use a Sporlan like CDS style 3-way valve used to almost temper the discharge, so they could like halfway split it. They were allowing some refrigerant to go through both, and I mean, it was kind of like an off-ball thing. I mean, it didn't really honestly work that well.
One of the other things to look out for, I stated before, it typically takes about anywhere from 3 to 3.5 hours to pump out. If it's not pumping out at all, you want to go right to the check valves and make sure that the solenoid, in fact, is pumping out the refrigerant. A lot of times in a lot of these racks, you'll have, typically you start having problems during the wintertime when it gets cold. They might have done a PM where they changed out some contactors. A lot of times what will happen is the pump out line will actually go through some of the auxiliaries for the contactors. And what could potentially happen is if someone wires something up one way or another, maybe the split valve never turns on because they goofed up when they installed the auxiliaries on the contactor. The purpose of that is they don't want any liquid refrigerant getting thrown in the header where it is going to pump out if there's no compressors running. So, I mean, that's the reason for it if you see it out there. I know Hill Phoenix is big on that. I think Kaiser does it. Do you know of any other manufacturers, Kev?
No, not really. But I have an interesting one with that. So I was at a big box store, one of the ones that I don't want to say the name. I'll get in trouble again. I was at a big box store and we had taken down the freezer because the floor had heaved up and still had maybe 10 coils running on this rack. Well, it had no load, no unloaders, bunch of compressors out. So they kept losing refrigerant randomly in the middle of the night and nobody could figure out what was going on. And every time somebody got there, all the gas was sitting in the split side of the condenser. It's freezing cold in Chicago. Come to find out that Hill had wired the split valve through the auxes on the contactor also. So the pump out and the split valve. So every single time all the compressors shut off, the split valve opened. It was doing this hundreds of times a day.
I've seen where, typically it depends on the manufacturer, right? You have the sets of auxiliaries that are through and through, right? And then you have the ones that are, basically have the normally closed, normally open, and common on the one side. And therein lies a lot of confusion for technicians. I don't know what the hell it is whenever they have to change one to another. And I had something similar where, we didn't find it until it was starting to get cold, and basically the liquid level would go from 40 50 or 60%, and then all the way down, and it would do this all day long. And basically it was because someone backfed voltage through a crankcase heater that would backfeed and power not only the split valve temporarily, but then the normally open valve. So it was doing the same thing. And the three-way valve, it ended up failing because it was running, you figured about, even if you figure on the low end, 200 times a day, and then 200 times 365, because it was a year since the contactor was installed. Do the math, it was hundreds amounts of cycles a month. So it just wore out that OE35 real quick.
Yeah, that's not good. Yeah, I ended up rewiring that, even though it was done for the factory. But I mean, you don't want the split valve shutting off when all the compressors shut off. You want the pump out line to do it, but you want the split valve to only be controlled by the EMS relay. Another thing to watch out for if you guys have stuff that's not splitting or stuff that's going in and out. I see this a lot on Hussmann racks. They do a pressure control override. So, and Zero Zone does this too. So they do like a pressure control override that hard locks out the split valve. So if it gets, say like 200 pounds or like 250 pounds, it's going to override and hard, break the power and kill the split valve. I see this all the time and guys miss it. And next thing you know, the split valve is, opening and closing randomly, and it's that mechanical pressure control that's causing the issue.
Good point. I've never actually found that one had failed, so that's a good find.
Yeah, that's a common Aldi thing, and and Costco. That's on the older Hussmann racks, but that's a common Aldi issue. So one thing I want to go over real quick is the microchannel splitting. So with the microchannel splitting, especially the Hussmann racks, so we're splitting entire banks of microchannels. We're not pumping microchannels out. So a microchannel usually only holds between two banks, only holds 18 pounds of gas. So there's no point in pumping out 18 pounds of gas. So Hussmann usually leaves refrigerant in the microchannel styles. So with those, on the Hussmann style, usually the way they do the banks and the microchannels, when the last fan on that bank shuts off, the normally closed of that relay, or I'm sorry, the normally open of that relay. So when the fan is normally closed, the normally open of that relay is tied to the OE35 split valve. So when each section shuts the last fan off of that bank, it energizes the split valve and splits that condenser. So that's why you really want to watch cycling the fans on the crack coils like that, because you're actually cycling the split too. So for that, I mean, you could have on an 8-fan condenser, you could have 3 stages of split. So that's one thing to take into account. I actually rewire those if I'm doing a job. I rewire them so that I can control the splits from separate relays. So that way I can split them and keep them split. And generally what I do when I'm controlling that stuff, especially the microchannel stuff, I will actually disable banks of fans in sections. So like maybe if it's like 50 degrees outside, I'll disable the first bank. If it's 30 degrees outside, I disable the second bank. What that allows you to do is it allows you to load up the first bank more. I'd rather run the first bank with more load on it than cycle the microchannels, because 2 reasons. If you cycle the microchannels, you're going to end up breaking them. I mean, let's be honest, those things leak like a sieve as it is already. The rapid temperature change is not good for them, but that's how they're doing that. So, I mean, you're not going to have any pump out lines on those unless the customer had them installed or is a customer spec, but they only hold 18 pounds of gas. So that's something to be aware of. So you want you're better off running on 2 fans. I mean, those microchannels are super efficient. So the more you can load the fans up, the better.
I've only had one store with those, thank goodness. I don't like them. I'm not a fan.
We probably have 300 Aldi, and if you set them up properly, they run great. And if you rewire the condensers and split them in banks, like they run amazing. Like we have no head pressure issues all winter long. We stopped cracking slabs. I ended up splitting it. So like I have 3 stages of split, and I split off temperature. And I mean, we don't crack slabs anymore. We hardly ever get a cracked slab. So I mean, there's tons of them out there, and if they're programmed properly, they run great. I mean, if you get the VFDs programmed right, but if you get a microchannel with no VFDs, it's going to be the Slab Cracker 5000.
When you talk about the slab, what are you talking about? You're talking about the actual physical condenser.
Yeah, the aluminum like V-style slabs.
Okay.
Yeah, so I mean, you'll see them like stress crack, and then they start leaking like a sieve. I mean, that's like the number one. They actually, I was told they stopped making those.
Really?
Yeah. But I'm not really, I can't really be for sure if they stopped making them. But yeah, that's one thing. So, and then for fans, so like splitting fans. So when we split that side of the condenser, we obviously want to shut off that side of the fans, whether it be microchannels or it be normal condenser. There's no point running fans on the side where the refrigerant's not going through. So you also want to split the fans on there. So you either have some kind of splitting relay, splitting odds and evens of fans, but you need to kill that side of the fans.
Like I said, I have really limited experience with those. I just know like having like a bunch of the OE35s, on those. I don't know. That's a lot of cycling on those valves. You know what I mean?
But yeah, I don't know. That's I'm not a big fan of microchannels just for the simple fact that they, I mean, the temperature change. If you take a infrared gun, do it, and just look at it when a fan cycles on. I mean, the temperature change is so rapid.
Because you get a lot of sensible heat change, but as well as a lot of latent as well, right?
Yeah, I mean, and it's an aluminum slab. I mean, it's just conducting heat like extremely well.
Gotcha.
So other than that, guys, I mean, other than making sure everything's pumped out properly and checking your split valves and checking that side of the condenser, I mean, once you guys go through that, I mean, you're pretty much golden. I mean, make sure you have power to your split valves. Oh, let's go over the Walmart stuff real quick. So like the Walmart and Sam stuff, generally the rack is not controlling the split stuff. Especially if you have a Danfoss drive. The Danfoss drive is controlling it. So some customers split off temperature, like Brett said, like 50 degrees, 40 degrees, something like that. Walmart splits off pressure. So they have specific pressure set points for each whatever refrigerant they have and whatever kind of store they're having, and they split off pressure. So if you have a smart Danfoss drive, meaning it's controlling the fans, so it's actually splitting off of pressure. So that drive is going to run those fans down to a certain set point, and it's trying to split at a certain set point inside the drive. When Brett posted, we could always post the spec for it, but it's trying to get the split down to a certain point, and once it's there for 5 minutes, as long as it's at or below a certain pressure for 5 minutes, it's going to energize the split and allow the fans to shut off halfway and the split valves to energize. And then once it gets to a certain pressure, it's going to de-energize the split and allow it to go back into full condenser. This is all done off the drive. Now there is a input to Novar to tell it that it's in split, but Novar is not actually controlling the split anymore. Even if it has relays and it originally was, it no longer is. So the Danfoss drive or the M400 Emerson drive is controlling these, and the drive does all the logic itself. So it's splitting in there. There's a relay. It's CR3 in the Danfoss cabinets that is actually doing your splitting. So that relay is actually energizing the contacts for the split valve. So if you look down like the bottom of the cabinet, there's interconnecting wires that go to the terminals for the split valve from the old condenser, like F9, I think, and I don't remember the other terminal. I think maybe F13 that is controlling the actual split solenoid from the actual condenser.
Well, because the relays are the fans are still controlled off of the CCM. So is it
not the split relay, because this split comes off of the CCM originally, most of the time. So it was coming back down into a terminal block in the raceway in the electrical trough. So what they did is you break the wires at the electrical trough. So when you energize the CR3 relay inside the Danfoss cabinets, it also energizes the split relay for the fans upstairs.
Gotcha.
It backfeeds power back up to the condenser, so it gets the split fan relay too. Okay. But that Danfoss drive is doing all your splitting. So there's tests you could do. There's an actual Walmart checkout for that Danfoss drive, and there's one for the M400 too, to force a split and check it and to force everything and make sure it's all working properly. But generally, what I see with those, I usually see pressure transducer issues. I'll see temp sensor issues. If the temp sensor is reading off, may keep the condenser pressure too high and it won't go into split. Or just generally, I find them wired wrong all the time, to be honest to you. I don't know. In the last 2 years, I've probably found 25 or 30 wired wrong. The split never worked. It never made it past commissioning, or whoever did it, faked it out to Novar to make it seem like it was in split. And it passed the drive install thing, but it was never set up right. I find them wired wrong all the time.
Is it because the factory installation or
it's the field? It's usually the field stuff. It's wires landing in the wrong spot. They didn't know where to land them in the condenser, or they crisscross stuff in the electrical trough. Generally, it's field wiring issues.
Gotcha.
Yeah. So, and then at the same time, that Walmart uses a bypass solenoid on the holdback. That's how they're able to get that pressure down. They actually bypass the holdback valve. They do this on all their stores pretty much. So there's a solenoid on the holdback valve. They're bypassing that holdback valve so they can get that pressure down. So the way that the split is set up, the normally closed of the split relay powers the bypass of the bypass in the holdback valve. The normally open powers the splitting solenoids and the pump out line. When it switches to go to split, it energizes the split solenoids and it de-energizes the holdback solenoid. So now your holdback is in play. So that way your holdback valve can't be in play and affecting the floating head pressure or anything else. So they bypass that holdback valve wide open until you're actually in split, till you actually need it.
Gotcha.
So Well, guys, I think it's a pretty good overview of the split side, a quick troubleshooting thing. Made a quick podcast for you guys. Just give her a listen, and thanks for listening, guys.
Catch you next time. Thanks.